Hello, I'm Nick Anastasi, Marketing Director with PWGC, and welcome to the PWGC Environmental Echo Podcast. Today, we will be discussing groundwater, the first of three topics related to water quality on Long Island. Joining me today is PWGC President and CEO Paul Boyce, PE and PG. Welcome, Paul.
Hey, thanks, Nick. Glad to be here.
Paul, at PWGC, we work with water on a daily basis, whether it's surface water, stormwater, groundwater. On today's topic, we're going to focus on groundwater in terms of since it is such a hot topic here on Long Island and in the New York City region, New York metropolitan region, I should say, in terms of its availability of supply, to its cost, to the treatment required due to the discovery of emerging contaminants and legacy contaminants. This podcast will discuss a variety of issues facing our groundwater on Long Island. And Paul, I'd like to start with the first question, since many of our listeners don't understand the uniqueness of Long Island in regard to its groundwater. Can you discuss where our water comes from and how it gets to the tap?
Sure. I mean, you start with, you're asking about groundwater, but it comes from the air, all right? It starts as precipitation, essentially. Condensation in the atmosphere that precipitates down, hits the earth, either as rain or snow or whatever it's going to be in a liquid form, and eventually it percolates through the earth and makes its way to the water table. Now, a lot of people don't understand or appreciate that when we talk about groundwater, it's not a giant cavern down beneath Long Island or a big open void or a lake or a river or a stream. It is solid earth, all right, from where you're standing down to whatever it could be, from a couple hundred feet to almost 2,000 feet down to bedrock, depending where you are on Long Island. And that is just filled with sand, gravel, silt, clay, combinations and mixtures of those. And that material is porous. And I've explained this to people in the office, maybe some of our administrative folks who don't really get, work with it like we do. But those pores, the particles of soil, they're not perfectly cubed and they don't fit together, side by side like bricks in a wall or in like the Egyptian pyramids. It's not perfectly like that. They're rounded, they're angular, and they have voids when they lay next to each other. And in those voids, when they get saturated, they're filled with water, okay? And that's what the groundwater is. It's the water that's sitting in the ground, not in a giant cavern or big open space beneath us. The island is not floating. We are connected solidly to bedrock. We're not going to drift away, but there is water in that saturates those voids. The unsaturated stuff, what's the unsaturated zone? That's the dry stuff before you hit the water table.
Understood. Now, could you quickly explain the difference or the uniqueness of Long Island in regard to where our water comes from versus maybe some other parts of the country or New York City?
Oh, absolutely. People may have heard the term sole source aquifer, all right? So all the water here in Nassau and Suffolk County, all of it that we get that comes out of our taps, okay, comes out of the faucets, it comes out of the shower head, it goes into your dishwasher, your washing machine, your hose bibs, the toilet, the sink, whatever. All that stuff's coming out of the ground, all right? It's what we call aquifers. If you look at Long Island, almost like a layer cake, all right? We've got multiple aquifers. We've got shallow ones, we've got deep ones. You start off with the uppermost and you work your way all the way to the bottom. There's four primary or principal aquifers, okay? And it's just a matter of where you are on the island, where you're pulling the water from or pumping it out of the earth to get it to those, fixtures in your home, or be it a hydrant in the street or an elevated storage tank that you might see in your local water district. And people often take this for granted, that, you are standing on top of your water supply, okay? It's under your building, it's under your parking lot, you're driving on it, you're working on it, you're playing on it. So, you got to just realize how precious or precarious that situation can be, depending on what you're doing, where you are, what you're working with, all of it, as I said, just how porous the ground can be. If you picture yourself on the beach, which is interesting, I tell people, and you take that cup of water and you spill it out on the sand, what happens? It's not being absorbed like the earth's a sponge. It's making its way down through those pores, and you see how quickly that stuff dissipates and gets to the earth, at least in the sand like that. It's a nice, uniform sand, but in other areas you may have tighter formations and it'll take longer, but there are places where the stuff, when you dump it or spill it, it ends up on the surface. It can get down to the water table quicker than you think, and you can have a real serious problem.
That's very interesting. Now, how do we differ from the way New York City gets its water from, I believe, from reservoirs.
Absolutely. New York City is primarily surface water. All right, so that is stuff that's flowing into those giant lakes and reservoirs upstate in the Catskill Mountains, the Delaware River water gap, whatever. They've got a couple of them. But if you think of the Catskill Mountains upstate, where they have those protected watersheds, that's just all surface runoff that ultimately flows in there. There may be some groundwater contributions, but primarily you're seeing a lot of just surface water, collecting there, and that's what they use for their drinking water. And there are some differences. You'll see differences in quality. Okay. What can get into the surface water a lot more readily as opposed to what can get into the groundwater. You talk about some of the surface runoff up there. You may have road salting operations this time of year. Those salts can end up in there. You could have waterfowl. You may have recreation activities taking place on top of those water bodies like boating and fishing, and think of the things that could end up getting in there that, obviously New York City's doing a great job treating the water. They're always, top water quality provider in the United States, as are the water providers here on Long Island as well.
On Long Island, with it being a sole source aquifer, should there be any concern as to the amount of water that's available? How much is there?
Oh man, that's a question that a lot of people ask me. After I get through telling them we're not sitting on an infinite supply of water. It's not that giant cavern. It's you can do some calculations, and the Long Island Commission for Aquifer Protection, LICAP, they've got some really good reports. We worked on, the geothermal portion of their, LICAP, the Aquifer Management Plan. But they do a little analysis where they try to give you a calculation of, how much groundwater might there be beneath Long Island, And if you look at Long Island as just Nassau and Suffolk as opposed to Brooklyn, Queens, Nassau, and Suffolk, there's some differences. But for right now, we'll just limit it to Nassau and Suffolk, all right, for Long Island. They estimate somewhere's on the order of like 65 trillion gallons of water, groundwater, beneath the island. And again, I explained that's from the surface down to the bedrock. And the bedrock is sloped, all right? It's much more shallow on the North Shore as opposed to it is on the South Shore. It's like I said, it could be a couple hundred feet to bedrock on the North Shore. Mm-hmm. And then on the South Shore, you could see it 1,800 to almost 2,000 feet in some spots. All right, so as it pitches down, and that porous material, all right? Remember I mentioned those pores in the sand? It's on average, you get about a 30% porosity. So that means when you pick up a handful of, say, dry sand or soil out of your backyard, and you have it as undisturbed as you can get it, it's going to be about 30% air, all right, in theory.
Okay.
All right.
Now, there have been many news stories in the region that have focused on the discovery and prevalence of emerging contaminants, as well as those legacy contaminants that have been there for some time. What are they? And well, let's start with that. What are they? What are the most relevant or prevalent emerging contaminants that we're facing at the moment?
Oh gosh, there's a few, but that the real hot topics lately you've seen in the papers and in the news and the TV would be the PFOA, PFAS type stuff. Those are really some of the bigger contributors would have been like firefighting foams. Where fire departments, whether it be at airports or whatever, they use the foams to put out the fires. That's one source where you may have seen those long chain type of...
and the PFOA, PFAS, those are perfluorinated compounds? You
got it. Don't ask me to spell out the whole thing because that's why it's abbreviated like that. But yes, and they are long chain compounds too, and they're interesting.
And what are some of the others?
The other real hot topic is that 1,4-dioxane that you guys have heard, and that was a stabilizer in, I believe... solvents like a TCE or a TCA. I'm not sure exactly which one. You also find stuff like 1,4-dioxane in you may have seen it in some laundry detergents, and all over the other places. And what's difficult about that, and we're seeing it everywhere, is if it wasn't stuff, say like a laundry detergent, out in Suffolk County where it's not sewered, what happens when you get done with your laundry? All that stuff washes down, goes into your sanitary or septic system out in the front yard or your backyard or wherever it is on your property. And what did I tell you about how water gets from the air down to the water table? It's going to percolate through the earth, reach the water table, and it's going to take some of those contaminants with it, and it gets into the water supply.
And what's being done to remedy these issues?
That's a tough one. You've got to treat it. If it's in the water, we absolutely can't. You don't want to be passing it along to the consumer. You don't want people drinking this stuff. As minimize it as possible. There have been standards set, which down to the parts per trillion. you know, and when you guys talk about trillions, I mean, it's almost hard to fathom. You know, they're throwing around $1 trillion, you know, stimulus packages on the TV like it's not a big deal.
Right.
Trillions is insane,
Right.
all right? And when you talk about parts per trillion, you know, if I had 1 trillion pennies and only one of those pennies was a bad penny out of those trillion pennies, the chances of you ever encountering it or finding it are going to be very slim, right? Just picture how many, you know, it's incredible. But as far as removing or treating those emerging contaminants, the PFOA or PFAS stuff, I don't want to say we're fortunate to be dealing with that stuff in any respect, but it's readily removed with like conventional treatment systems that we've been using for a long time, like granular activated carbon, GAC, what people may often refer to as a charcoal filter. All right, it's an organic type of material that it will absorb those contaminants right out of the water or the solution. And the 1,4-dioxane, that is a little trickier. All right, that doesn't come out of the solution or out of the water as easily. We're using what we call advanced oxidation processes, where we try to break down the molecules and you know, then pull them out using or destroy them using you know, ultraviolet light and hydrogen peroxide, and then ultimately maybe a carbon filter or something or whatnot to get all the pieces or parts out of the water. And that is costly. It's expensive. It's not cheap to maintain. So, you know, as the local water suppliers are trying to address this, you know, you got to imagine, you know, where's all this money going to come from? You know, obviously there's going to be lawsuits and this and that to, you know, go after the responsible parties, as there should be. But, you know, we got to address this immediately. And you guys know lawsuits and whatnot can take years and years and years to get that. So we can't wait. But it is not cheap. It's not easy. Some of it can be energy intensive. You know, it's not something anyone wants to look forward to dealing with.
Paul, is this an evolving issue in terms of the technology that's being developed? You know, we're now able to look at issues in parts per trillion. Where does this end?
Yeah, right. Where does it end? You know, parts per billion is 1 times 10 to the minus 9. Parts per trillion is 1 times 10 to the minus 12. You know, it's just, and again, I'm telling you guys, it's just the scale of this is it's almost unfathomable. As technology keeps advancing, I don't know, quite honestly. Parts per trillion, you know, when I started doing this, you know, 2-3 decades ago, it wasn't even fathomable back then. You know, parts per billion, you're like, ooh, wow. Now we're parts per trillion. You know, what's next?
Right. And then you alluded to it before, but the costs associated with this, some of these remedies are relatively inexpensive in regard to the PFOA or PFAS issue with the granularly activated charcoal. But as you alluded to before, the other remedy for 1,4-dioxane is very expensive.
Yep.
How can we prepare now to deal with emerging contaminants that we're bound to discover in the future?
My first step is prevention. You know, let's not get there. When I started this conversation, I mentioned we're standing on top of our water supply. We're working on it. We're playing on it. We're living on it. You know, anything you do has the potential to affect the groundwater. You know, the idea is don't let that stuff get into the water. You know, aquifer protection. If we could do that, we wouldn't have this wouldn't even be a discussion. You know, what's coming up or what's my crystal ball saying? You know, I mean, years ago in different areas, you know, the hot topics became lead, asbestos, mold, PCBs. You know, now we're onto these emerging contaminants like this stuff. A few years back, it was personal care products. You know, as I mentioned, like laundry detergent going down the sink. Well, you brush your teeth, you rinse, you shave your face, you wash your hair. You know, you take medications and they go through your body and they end up going into your front yard and ultimately down to the groundwater. And then what happens? You know, how are we supposed to even know what's out there? You know, those are tough questions to answer. You know, what's coming up next and what should we do to be better prepared for it? Because I wish I knew what was around the corner. You know, so I could come up with a solution in advance. But my best thing to tell you is, you know, let's not get there.
Right.
You know, prevention.
Well, there's a wonderful segue to my next question in that much of Long Island, much of Suffolk County, I should say, is not on sewers or commercial wastewater collection and treatment systems. So what you're saying in terms of the chemicals going straight into the ground, obviously is very accurate. But one of the other issues that the region is facing is related to nitrogen. and
Oh, yeah.
and your septic system. Is nitrogen impacting the groundwater in the same way that the other emerging and legacy contaminants are?
Yep. And nitrogen's got a standard, drinking water standard too. You don't want to be consuming, copious amounts of nitrogen. It's not going to be good for you. Okay. Also, it has other effects besides the human health. There are environmental effects. The groundwater and the surface water here on Long Island are all sort of interconnected. You guys have seen the brown tides and the fish die-offs and, the blue algae and the blue-green algae, the cyanobacteria, all that stuff. Nitrogen is a nutrient. So when it's out there in the environment, not only can be harmful to human beings, it's harmful to the environment in those large amounts. And we have been, since the post-World War II boom out here on Long Island with, development, and the lack of sewers. So stuff's been going into the ground for 60, 70, 80 years, How long is it going to take to get that stuff back out, And as it got worse and worse, you got more and more. So it's a problem we have to address. We should have been addressing this a long time ago.
Paul, municipalities across Long Island are working to address the nitrogen issue. Suffolk County's Reclaim Our Water program comes to mind. What types of projects have you been a part of that have worked to improve this situation?
Yeah, Nick, it's been pretty diverse. We have worked from the residential level all the way up to the municipal level to, get involved with this. And it goes right along with our mission, to be a leading provider of those environmental services for a sustainable and resilient future. If we don't protect the groundwater now, it's not going to get any better. So what we have done, if you look at the residential level, they have what they call these innovative alternative on-site wastewater treatment systems, IA systems for short. And what that is, it's to reduce the amount of nitrogen coming out of your house and basically making its way to the groundwater. It's not going to remove 100%. It's going to remove it down to a much lower level than it would untreated. It does take a little bit of an appetite to do it because it's going to cost some money to put the system in, to have it designed, and maintenance. It's a mechanical, biological process to help break down some of the nitrogen before it makes its way to the water table. At a grander scale, and which is certainly more effective because it will remove all the nitrogen, is sewering. And we are working on a couple of county projects, Suffolk County projects, to sewer certain portions of the county. And that'll be a collection system, hooking people up, taking them off their septic systems, putting them on sewers, which will eventually flow to existing county sewage treatment plants. And they treats it down to less than 10 milligrams per liter of nitrogen. And then there is take like a plant like Bergen Point in Babylon area, okay? That has an offshore outfall, and they're currently redoing that outfall. It's 2 or 3 miles offshore, and so whatever nitrogen's left, it's going out into the ocean. It's not going into our groundwater. As the surfer in me, I have separate issues with that, but as the engineer and the guy that has to live here on Long Island and drink this water, sewering is a terrific way to do it. Again, the drawbacks is it can be very political. It is expensive. It's intrusive. We got to rip up roads. We got to disturb houses. And did I say it's expensive? It's expensive. All right, but it is very effective. Unfortunately, we should have been doing it decades ago. But we are where we are, and the time is right, and we do have some political leaders with the appetite to take this on. And at PW Grocer, at PWGC, we are a part of that solution.
And in regard to the PFOA and PFAS issue that is facing many locations on Long Island, I know that here at PW Grocer, we've been working with the county on a project in Yaphank in terms of developing a system to deal with the problem. Could you elaborate on that?
Sure. Those are county properties that are on wells. There are still homes that aren't hooked up to public water supply here in Suffolk County, and there's probably some, I'd imagine, in Nassau as well, but not nearly as many. So these wells have got some contamination with these PFOA, PFAS compounds, contaminants, and we've got to get them removed before people use the water, consume the water. And the way we're doing that, as we mentioned, was the carbon-type filtration, the filters. We call them POET filters, point of entry treatment. POET, real creative. but they work. So as it comes into the residence, we filter out those contaminants. And again, this isn't a set it and forget it solution. Eventually, that carbon in that filter is going to get depleted, and it needs to be replaced or regenerated. And you have to carefully sample so you know when you're getting to the point of breakthrough. And you want to know before you get to breakthrough, so no contaminants make it to the end user.
This project brings to mind something that I think would be very educational for our listeners, in that the groundwater that we've been discussing is not static. Please correct me if I'm wrong. There is quote unquote groundwater flow. And so the contamination of a given site, let's call it 123 Smith Street, while the contamination may take place there, the contamination can flow from point A to point B, and obviously we're seeing this both at the former Bethpage facility of Northrop Grumman, as well as at the former Naval Weapons Reserve plant in Calverton. Yep. Could you elaborate on that?
Yeah, absolutely. Now you're getting really to a subject that's really near and dear to my heart, and that's like groundwater hydrology. Okay, and that is, it could be fate and transport of those contaminants, or if we just want to talk about the straight hydraulics. Once it enters the groundwater, okay, as you mentioned, it's not static. It is a dynamic environment. Groundwater is moving generally. I mean, it's not moving as fast as you can walk or run, but it might move half a foot a day to a foot a day, maybe a little faster than a foot a day, depending on where you are and the type of gradients. And what I mean by that is you may have a difference in, say, pressure or head elevation type of head, and that water may move faster or slower depending on what's driving it.
Paul, head being?
How's the best way to explain that? It's a combination of elevation and pressure.
But in essence, it's
pressure
the pressure
head, elevation head.
It's the pressure being pushed down on top of.
Essentially.
Okay.
All right. It's not like like a pressurized container or anything. It's just water pressure is essentially what we're talking about.
Okay. Speaking of contaminants, although people may not think of it as a contaminant, in many instances here on Long Island, especially on the shorefront areas, there are issues associated with saltwater intrusion. Can you explain what that is?
Absolutely. Again, another topic that I find, fascinating, and I don't want to get too passionate about it, but it is something that I'm into, all right, for a variety of reasons. But as you start to withdraw water from the aquifer, okay, you're going to start to draw down water levels. You're going to decrease the pressure, okay? And at the shoreline, people may have heard of the saltwater interface, all right? So that is the point where we go from freshwater to saltwater or vice versa, depending on where you're standing. If we're on the landward side, we're going to be standing hopefully over the freshwater side. So on the interface, the other side would be the saltwater. As I start to remove water from the aquifer for consumptive purposes, and it is being replaced, we talked about where's it come from and how's it get there, but if we start to pull out more than we're replacing it with, we'll create this deficit. All right, and that'll create this pressure gradient where the pressure offshore now is greater than inshore, and that saltwater interface can either move horizontally or vertically. So if it starts to move horizontally, it's going to start to slide inland towards you, hence saltwater intrusion. Obviously, everybody knows you can't drink saltwater. All right. Starts to taste salty after at pretty low concentrations too. If you guys have been in saltwater pools and stuff, you can, or if you go out in the ocean there, it's like, the chloride concentration's like 35,000 milligrams per liter. It's insane. All right. But the drinking water standard's about 250 milligrams per liter, as opposed to seawater, and this is, chlorides, it's about 35,000. All right. So I hope that explains, and like I said, you have the horizontal translation or movement due to pumping, and you can have vertical, which often we call upconing. So if I have a well and my saltwater interface, it's not a vertical line, it's kind of like a wedge shape, all right? And I start pumping and lifting that water up or out of the aquifer, I can start to have this upcone of the interface too. So you can have horizontal translation and vertical translation.
In terms of treatment for the contaminants that may or may not be in the groundwater, what else is in the groundwater in terms of are there minerals? Are there other?
Absolutely, Nick. It's not deionized water down there.
Right. It's not simply H2O.
Nope. There are naturally occurring organics and inorganics. You may have iron and manganese. You may get some fulvic and fulvic acids, tannins from like organic matter that might be present in there. At low concentrations, these things are normal and not harmful. But like take iron, for instance. All right? Nobody wants to take a sip of water and taste like they just drank out of a rusty can, right, or a rusty pipe. It's aesthetic, generally. It's going to have smell. It's going to have taste. It can stain. You know, we've all seen a ring around, say, a toilet or in a sink or a tub or a washing machine, and it looks rusty. It's often you have high iron problems. But you do have other things just besides H2O molecules in the water, and they're not harmful. Again, as long as they're in the right concentrations. And what the water providers or purveyors here in Long Island, they have standards they have to meet, and they are providing, you know, fresh, clean, potable water to everybody.
Paul, earlier you had discussed the amount of water going into the aquifer on an annual basis. How much is being pumped out?
Well, you know, Nick, if we just again look at Nassau and Suffolk County, we're somewhere on the order of approaching 3 million people between those two counties. It's probably about 2.8, a little bit less. And if I remember correctly, if I go back to what I mentioned, that LICAP report, you know, they do that State of the Aquifer report every year. It's a great document.
And LICAP is?
The Long Island Commission for Aquifer Protection.
Okay.
All right. PW Grosser is a member of that. We do support that. But what they had written is you see about 45 inches of rainfall or precipitation here on Long Island in a typical year. And on average, about half, somewhere around 22 to 23 inches, makes its way to the water table. Like I explained, it percolates down through the porous soil and it gets in there. So when you start to think we've got going on about 3 million people here on the island, how much water are we using each year? Sort of referencing those reports again, it's somewhere in the neighborhood of maybe 150 billion to 200 billion gallons a year. A lot of water.
Wow.
All right, but when we go look back at the area of Nassau and Suffolk County and we say, okay, let's average it out at like 22, 23 inches of water over that area, how many gallons does that equate to? That's in the neighborhood, I think, of, if I do my math right, somewhere around 300 billion. Still more than we're taking out, all right? But we are taking out a lot. You know, so we have to be careful on how we manage this very precious natural resource.
Are we seeing, or is LICAP seeing increases on an annual basis in terms of water usage?
I think it's been fairly steady for the last couple of years. I mean, if you see a drought year where we don't get that 45 inches, you know, people are going to be watering the lawn a lot harder. And you are going to use a lot more water. There'll be evapotranspiration, which it's the uptake between the roots and what evaporates, and some still will make it through as waste as it gets back to the water table. But the irrigation systems, they can kill you. They can really drive up your water usage. As you know, as we grow as a community too, more and more people, there'll be more and more usage.
That was going to be my next question. As the Long Island region evolves and real estate development evolves with it, and we're seeing more and more multifamily developments as opposed to the traditional single-family home being developed. Do those types of facilities use more or less water?
A little bit less, yeah, because if you're looking at then those single families, they're kind of clustered together. They don't have the yard, and they're not using as much irrigation. You know, they still may use on a daily basis in terms of doing laundry and, you know, washing bathing and cooking and cleaning. And depending on what kind of facility they're in, it's usually a little bit less than, say, a single-family residence.
Okay, so multifamily will use, on paper,
yep,
will use less water per annum than a traditional single-family home.
Correct.
Understood. So, Paul, you alluded to conservation as being a key to addressing these issues associated with water quantity as opposed to quality. I know that we at PWGC we work on these types of projects on a daily basis. What would you recommend as the best methods to address this issue?
I mean, we do work with some facilities and institutions in terms of helping them curb some of their consumptiveness or habits. You can look at low-flow fixtures, be it a toilet, a sink, a shower. Those come with other issues, which may be better suited for another podcast again. But one of the biggest ways here on Long Island is irrigation. You know, if you really want to put a dent in doing something for, you know, curbing our consumptive habits, I'm not advocating for everyone to put in an artificial lawn or, chop it all down and go back to the woods. But if you go back to more natural type grasses, more natural type plantings, drought-resistant plantings, the xeriscaping, if you will, it's not as attractive as the green lawn, but it certainly does have an impact.
Thank you, Paul. That was very informative.
Thank you, everyone, for joining PWGC's Environmental Echo and for discussing the importance of groundwater, the first of a 3-part series. Please go to pwgrocer.com if you have any questions or comments, and also subscribe for our podcast.